So for number 2, I'm not very confident in my answers, but okay, so I kept it to draw the solid or the regional integration, and I drew it in this fashion because I thought it would be easier to see. So pretend the x-axis is coming towards the door. So there's the y, there's the z. So just looking at what they give us, dy or dz, dy, dx, z goes from x squared plus 3y squared, which is an upward opening paraboloid. So it's kind of like this. And then goes from that to 4 minus y squared. So that's a paraboloid, or whatever they call it. So you can imagine this, like this parabola in the zy plane extends infinitely out towards the door. And then in the xy plane, we have y going from 0 to 1/2 4 minus y squared. Y goes from 0 to this. So, but if you simplify it, it's just x squared plus 4y squared plus 4, which is an ellipse in the xy plane. And we want y going from, or they want x going from -2 to 2, but y goes from 0 to that, so just the upper half of the ellipse. So going back to this region, we just want this part right here. So since x is going this way, we want all the positive x's, or the positive y's, and then the x going from -2 to 2. So there's nothing over here. Okay, so the first change of integration is dz, dx, dy. So that's over here. So dz is the same, so the most inner bounds should be the same. X squared plus z equals x squared plus y squared to 4 minus y squared. These are the same. And then here, instead of dy dx, we want dx dy. So instead of taking the horizontal distance, we're taking the vertical distance. So the vertical distance goes from here to here, but that's just the top half of the ellipse. So if we solve the ellipse with respect to x, solve it for x, you should get x is equal to -4 minus 4y squared to 4 minus 4y squared. So from here to here, and we're going from 0 to 1, because that's the where the ellipse ends. So pretty sure this will be the right answer for dz, dy, dx, dz, dx, dy. Okay, so second one I'm less sure. So second one, they want dy, dz, dx. That's over here. So I first looked at the shadow in the zx plane, which is over here. So if you look at it this way, since this parabola extends infinitely out the door, since dx is this way, so we want this plane, and then this plane is capped off by this parabola at 4, because that's the equation for the paraboloid. Z equals 4 minus y squared. And since we only want the zx plane, y is 0. So this is just z equals 4. So instead of z being 4 minus y squared, since we're only looking at the shadow in the xz plane, y is 0. So that's just z equals 4. And then this is the bottom paraboloid that comes from the upward opening hole. So the equation for that is z equals x squared plus 3y squared. And once again, since we're in the xz plane, y is just 0. So that's part of that bound. But in this case, this equation just z equals x squared. This y is 0. Does that make sense?
Where do those two parabolas?
It's okay. So this parabola is 4 minus y squared. This extends infinitely out towards the door and into the board.
Yes.
And then this, like that, like this, and this is
Then I'm
like
at this point. Where is that point?
Z y equals 1.
If anyone wants to see a picture of a really nice drawing, I could put on the projection.
really nice.
It's like probably one of the better drawings actually done, which I'm proud of.
Okay.
Yeah, so that's like a picture of that.
So for the second one, we're looking at the xz plane. So it'll be that plane over here, and so it goes to z equals 4, and this part is just a parabola in the xz direction. So when y equals 0, so it should be z equals x squared, since it's y equals 0. So so for the outer bounds, we're doing in terms of dz dx. So z will go from the parabola, which is x squared to 4, x squared to 4, and then x will go from -2, that's where they intersect, -2 to 2. So those are the outer bounds for this. And y, I was less sure, but I came up with this. So y, if you're traveling in the y direction, you're first going to hit x or y to 0, because that's where it starts, and you're going to come out over here, so out of this paraboloid. So which is, which I just, so the equation for that is z is equal to x squared plus 3y squared. So I just solved that for y. So if you subtract x squared on both sides, divided by 3, take the square root. Since we only want the positive direction, it's positive. So
The only problem I see is that I feel like it also comes out of the
top.
Yeah, top two. So you have to split the integral, which I didn't do, but I saw it.
Yeah, that was the part.
Considering your other
But-
bounds look right.
But do you all agree that these bounds are right?
Yeah.
Okay. So then how should we split this or split the y?
We just need to find a equation for like a bound for z where this curve has a shadow on the zx plane.
So we basically have to split them into two halves, two parts.
Like what should have like for y?
So didn't you like come up with that? Or actually split them? Yeah.
So yeah, it's like this is the projection of this curve onto the x zy to zx plane, and like I was looking at it, and where y is, excuse me, where x is 0, z is 3. So it reminded me a lot of the curve of like the bounds for x and y in the original. So I thought it'd be like the same form of that equation. So like I guess that was an assumption on my part. Like it seems reasonable, but I'm not sure. So I just turned it upside down and shifted it up the center up 4. So then we have, this would be the bound, maker bound for z, when we have that bound for y right there. And then from that z bound up to 4, the y bound would be root 4 minus z, which is the paraboloid part. Or the parabola, it's actually parabola. Does that make sense? And was my like assumption that curve was like the projection was the same as the original, like fair? I think.
Can you explain that one more time? That extra curve.
Oh, this curve.
The inside of the.
Yeah. Easier if I can show like what's above. So this curve up here is the bounds for x and y in the original. So like that, this just goes from like 1, like over 2, like over 2. Like it's that curve like that. And I guess this curve here reminded me of that because it was like the same relative I guess like distances for the curve on the projection. Because the z, the lowest z is 3, and then it goes up to 4 with going 2 out. So I figured that like any 3 points give the same curve, so that would be like the same general form of the equation. And then from that, I took a negative 2 of where did I stop it?
So you just like flip that top curve down. Does it look the same?
Yeah, I flipped it and then shifted it up to 4.
Yeah. That might work. But I'm not sure. I think like a surefire way to do it would be to find an intersection between like this surface here, down here, and this surface.
Yeah, that's what I did, and that was like that equation right there. With y equals 1/2 root 4 minus x squared. Like it doesn't have to give anything in terms of z for that. And that was the same form as the like the shadow of x and y.
Why squared?
Y is what?
Why 2y squared? 4 minus x squared. Isn't it 4 minus
Chris, did you intersect the two surfaces?
Yeah.
You showed?
Oh,
I did
yeah,
that.
okay, yeah.
Yeah. Want to do it on the board?
Yeah.
So then you fix it so.
So that would change that.
That would see like self-correction.
Yeah. How will that change the answer?
It doesn't use self. You fix it, now fix it with it, so.
Oh, I did. Oh, I see. I made another error and like didn't take the square root of like of 2.
Correct answer.
Yeah. Yay. So that was fortunate, I guess. Yeah.
So we can intersect the two surfaces.
Wait, what's the equation for this one?
Z equals 4 minus y squared.
And then this one's z equals
X squared plus 3y squared.
Yeah, so you're cutting right about z equals 4, right?
What?
You're cutting right about z times z equals 4.
Yeah, so like for this is like what the bottom part with where y goes to the paraboloid, and this is like up to z equals 4 for the parabola part.
So are we supposed, if you solve for an intersection, don't we want something, don't we want those equals something x? Or no, we don't need the y because it's the x point, right? We want to get rid of the y.
You can just hold it, set
I
y
can
to
just
0.
set y to 0.
Yeah, so you're gonna,
So I get x squared equals 4.
that's.
Or x squared. X equals, wait. That's just a line, equals 2. Does that make sense?
Guess it could cut it like uniformly, it might not bend the way you thought originally.
How about eliminate, instead of solving for z, what if we just simply solve for y?
Oh, yeah.
Maybe z equals 3 plus 3/4 x squared.
Z equals 3 plus x squared. Is that what you got by doing your flipping method?
Oh yeah. Yeah, that's not what I had, I don't think, no. Okay.
I have something very similar to that. I cannot guarantee it's the same because I'm talking about the questions.
let's see if this seems reasonable, so that's z equals 3, so we start up the height of 3, and then plus x squared over 4, so some kind of parabola that isn't very steep.
Chris, how do you get from the third step to the fourth?
Third step to the fourth. Okay, well this is this equation.
Right.
And then this part, I moved y squared to this side, so it's by itself, so I'll just go back. So y squared equals 4 minus c. And then I noticed that this is 3y squared, so I multiply this whole thing by 3.
Right, okay.
So that's 3y equals probably 3 in the sentence equation.
Yeah, that's more reasonable.
Okay, so just to clarify, so z equals 3 plus x squared over 4 should be
Yes.
here.
Yes.
And down and down. Okay.
Fix one here.
Oh, yeah. So it will be that. So oh, this was right? Yeah, and then just add the second part.
So why don't you write a function that all will integrate
Oh,
one? Just like,
I don't think that was important.
yeah, okay.
Oh,
I
okay.
think it's not like for some reason.
Yeah, x cubed plus y cubed.
Yeah.
Yeah.
Just like, but it should be there, right?
Yeah, it should be there. Yeah.
Yeah, just.
So, okay, so the third integral is dx dy dt. So now we're looking at the yz shadow. So that is okay over here. And so so we know in the yz plane x equals 0. So if you look over here, we just have like two parabolas basically. And then this one is just 4 minus y squared, and then the other one is z equals 3y squared. And since x is 0, x squared equals to 0. So, and since we only want the positive xy, or in the positive y direction, we're only interested in this part. So that part right there, we want dy dz. So y will go from this bottom parabola, which is z equals 3y squared. If you solve for y, it's square root of z over 3, up to this downward facing parabola, z equals 4 minus y squared. If you solve for y, it's square root of 4 minus z. They're both positive. And we want from 0 to 4. So it should be like going this way, but wait.
Yeah.
Don't we have to different, don't we have to separate that as well?
Yeah.
The other way?
Because
I think it's just, we're only interested in the right part, right?
yeah, but still like above when we're going to intersect it's different thing like below.
Yeah.
Like above you're gonna have something that's like more nature like this, and below you're gonna have it like this.
I think because like, is that a zy graph?
Yeah, y, yeah.
So y would be from like this axis over to the curves.
Okay, I see. I think I did it the other way, but okay. Now I see. Yeah, so we have to go from y equals 0 to here,
Going down.
like to the parabola, right?
Can you put your picture? Like this, you have to go from here, because here it's not a straight line. You have like this curve that's going down. It's not like you just cut from here to here. No, it's from here to this equation. I don't know if that makes sense. So you need to cut like from here, like all white from here to this one, this one, this one, this one.
But if we're just looking at a shadow, it's
Yeah,
gonna
the
be
shadow
white
is
plane, then it's just going to be cut off.
I don't think so.
Is it cut off at a line though?
I don't think so.
I mean, I assume that, and based on that assumption, I'm probably wrong.
If you equal in both equations, they're I don't think you do that.
So, like, I think to do this third integral justice, we need to spend 15 minutes on it. So maybe we can table this one for now and move to other problems. But if you have any questions about the second one, now is the time to ask them. The one that we broke up into two pieces.